In this video, we are going to be looking at the lesson called Fractions and Pattern Blocks from your Jump Math book, page 57. So if you want to pause the video, open up your math book please to page 57 so that you can follow along. Hi, welcome back. Okay, so for today's lesson, we're going to be combining fractions with shapes. So we're going to be looking at 4 shapes today. So it's a bit of geometry as well as a bit of fractions. So let's get started. So let's take a look at this shape. Does everybody remember what this shape is called? That's right. It's a triangle. We're going to talk about the properties of these shapes in just a minute. What's the name of this shape? I wonder if you've taken that in grade 2. That one is called a rhombus. Rhombus. Do you know the name of this shape from grade 2 geometry? That's called a trapezoid. And finally, here's a 6-sided shape. Do you know what the name of this one is called? That's right, it's a hexagon. Okay, now we're going to talk about some of the properties of these shapes. Okay, so when you're looking at 2D shapes, there's a few things you want to note. First of all, you want to think about how many sides the shape has. So a side is this part here. The side here, and there's a side on this one. So now when we think about sides, look at a triangle. How many sides does a triangle have? If you said 3, you're correct. There's 1, 2, 3 sides to a triangle. Let's take a look at the rhombus. How many sides does a rhombus have? If you said 4, 1, 2, 3, 4, you're correct. The side is the part along the edge. A rhombus has 4 sides. In fact, a rhombus is kind of like a square in that it has 4 sides and the sides are all of equal length. However, you'll notice a rhombus, its corners are not right angles. Okay, so that's the difference between a rhombus and a square. Let's take a look at a trapezoid. How many sides does a trapezoid have? If you said 4, 1, 2, 3, 4, you are correct. And finally, let's take a look at the hexagon. How many sides does a hexagon have? If you said 6, you're correct. 1, 2, 3, 4, 5, 6. A hexagon has 6 sides. So that's one characteristic of a shape that we're going to be looking at today, but there's other ways that we can look at shapes. Let's take a look at parallel sides. Now when something is parallel, it means that the 2 lines are side by side and they never touch. Never touch. They're always running side by side. Okay, they might run this way, side by side, kind of like railroad tracks. They run side by side, but they never touch. So if we think about parallel sides, I wonder if you can find the shape that has parallel sides. Does a triangle have parallel sides? 2 sides that never touch? No, it doesn't. If you'll notice, all the sides go into a point that eventually touch. How about a rhombus? Does it have parallel sides? Well, let's take a look. Do these 2 lines and sides ever touch? No. Do these 2 sides ever touch? If we were to continue those lines down, those sides would never touch. So a rhombus has 1, 2 sets of parallel lines. Okay? Let's take a look at a trapezoid. Does a trapezoid have any parallel lines? Well, let's take a look. Look at these lines here that come in. If I were to continue that line down, eventually those 2 lines would meet. These 2 lines are not parallel. But how about these 2 lines here? Are those 2 lines running parallel like a train track? Yes, they are. So that has 1 pair of parallel lines. Let's take a look at a hexagon. Does a hexagon have any parallel lines? Well, let's see. Are these 2 lines parallel? Nope. Are these 2 lines parallel? Nope. Are these 2 lines parallel? I think so. All right, so parallel lines means the lines, they would never touch. They just run parallel to each other. You can probably find parallel lines here in a hexagon. And look at that, parallel lines there in a hexagon. So a parallel hexagon has 1, 2, 3 sets of parallel lines. That's very interesting. And finally, I want us to talk about vertex of a shape. You'll notice that the corners of a 2D shape, where two sides meet, that creates a corner. That's called a vertex. V-E-R-T-E-X. That's one vertex. If a shape has more than one vertex, 1, 2, 3, and a triangle, that means it has 3 vertices. 3 vertices. Okay, that's the plural of vertex. So wherever two sides meet, that is a vertex. You'll notice that there's a vertex here and here, and here and here. A trapezoid has 1, 2, 3, 4 vertices. And a hexagon has 1, 2, 3, 4, 5, 6 vertices. Now the really cool thing about geometry is that if a shape has 3 sides, well, guess what? It also has 3 vertices. If a shape has 4 sides, 1, 2, 3, 4, then it also has 4 vertices. Same with the trapezoid. There's 1, 2, 3, 4 sides. Well, guess what? 1, 2, 3, 4 vertices. Same with the hexagon. There's 6 sides, and of course there's 6 vertices. Okay, so that's a review for you, just so that you're familiar with the shapes that we're going to be using today in our fractions lesson. Okay, so you'll need to know words like triangle, rhombus, trapezoid, hexagon. You'll need to know words like sides. You'll need to understand the word vertex being a corner and vertices being many corners. And I think those are the main points. Okay, so let's start talking about creating fractions within these shapes. Now, if I take a look at a rhombus, I'm going to go from vertex to vertex, and I'm going to draw a line down connecting the 2 dots. How many triangles did I create on that rhombus just by separating it with that line? Can you see how many triangles have been created on this rhombus? If you said 2, you were correct. Let's take a look at this trapezoid. How many triangles can I create on this trapezoid? Well, to check that out, I'm going to connect the dots. There's 1 connection, 2 connections. How many triangles can be found on a trapezoid? You're right, it can be divided equally into 3 equal triangles. Now the hexagon is a little bit more complicated. I see at each vertex a dot. How can I divide that one into equal shapes? Well, there's one step that you have to take first. You have to find the middle point. Once you find the middle point of a hexagon, you can create equal shapes, and it's really cool how you can do this. Draw a line from each vertex to the center point. And what do you get? You get 1, 2, 3, 4, 5, 6 equal parts. Isn't that cool? 6 equal parts can be made on a hexagon. Now, I want to show you something interesting. Let me get rid of that. I'll draw one more hexagon. Now, the fun way to draw a hexagon is to just draw 6 sides, all equal length. Did you see that? Now, let me ask you this. If I put my dot in the middle and I draw 1 triangle on my hexagon and I shade it, is that telling me that I have, what would be the fraction for that part right there? What would be the fraction for that part? We know this is a hexagon, so I'm going to erase this. What is the fraction for this part? Is it 1/2? Or is it 1/6? What do you think? Is it 1/2 or is it 1/6? If you said 1/6, then you are correct. Because here's the thing. Look at that fraction. Is this equal to this? Is this shaded part equal to the non-shaded part? No, it isn't. This part is a lot smaller than this part, which means we have to imagine by joining up all the lines to the vertices that all the other equal parts are there, which means there's 1, 2, 3, 4, 5, 6. There are 6 equal parts in a hexagon, and one part has been shaded. Okay? Again, it was not 1/2. It was 1/6 because we had to draw in the equal parts. Does that make sense? Okay, let's take a look at some other shapes. I'm going to erase this now that we know our different shapes. All right, let's take a look at a hexagon again. I'm going to draw a nice big one. How many sides in a hexagon? That's right, there's 6. Now, if I want to find the fraction of a hexagon, and I draw a line right through the middle, what 2 shapes did I create here? What is the name of this shape? If you said trapezoid, you're correct. There's a trapezoid here and a trapezoid here. If I were to shade one of them, it's kind of a big one, what would be the fraction for that shaded part? How many parts did I count? I count 1 part. The bottom number, or the denominator, tells me how many parts there were in total. There was 1, 2 trapezoids on this hexagon, so I'm going to write that there were 2 equal parts. The fraction for the shaded part is 1/2, but I can divide that hexagon many different ways. I'm going to draw that center point again, and I'm going to divide it like this. What shapes did I create now in this hexagon? You're right, I created rhombuses on this hexagon. If I were to shade one of those rhombuses, what is the fraction for that shaded part? Well, the first thing I'm going to do is decide how many parts are shaded. 1. I count 1. How many parts are there in total? How many rhombuses are there in total on this shape? 1, 2, 3. That means 1/3 of the shape has been shaded. Okay? Numerator tells me how many parts I counted. The bottom number, or the denominator, tells me that there were 3 parts altogether. Okay? So you are going to be looking at hexagons, and you are going to be dividing them up so that all parts are equal, and then you're going to be writing the fraction for it. And here's the thing, the book is going to try to test your mind a little bit by throwing in things like this. Tell me what you think the fraction is for these shaded parts. What do you think the fraction is for that one? Is it 2/4? Or is it 2? I wonder what that denominator could be. Well, I see that this part is not equal to this part. This part is not equal to this part. So I do not have all equal parts. That's telling me I have to make all equal parts. So I'm just going to finish drawing in the missing lines. What is my denominator now? Can you count how many equal parts there are? If you said 6, you're correct. 2/6 would be the proper fraction for that. We could not use 2/4 because there were not 4 equal parts. So we had to create the equal parts. Now there's one more thing I want to show you before you get into these pages. The last question, number 6, takes 2 hexagons. And they draw them like this. They connect them. Okay, there's 2 hexagons. And then they're going to do something like this. What is the fraction? What is the fraction for this shaded part? And you're going to be thinking, wait a minute, this part is definitely not equal to this part. This part's way too big. What's the first thing that you should do then when you notice that the parts are not equal? If you said make all the parts equal, you are correct. The first thing I'm going to do is draw the line to separate my two hexagons. But are these still equal? No, they are not. So if you remember, I'm going to draw a line to each vertex. Watch this. Do I have equal parts on that side? Pretty equal parts. But look at, is this equal to this yet? No, it isn't. I need to create equal parts. So I'm going to draw my center dot because that's my guiding point on drawing a hexagon, triangles on a hexagon. And I am going to create equal parts. Now, can I write a fraction for this shape? Oh my goodness, I can because all the parts are equal. First, I'm going to count how many shaded parts there are. Can you count how many parts are shaded? That's right. 1. Your next job is to find out how many equal parts you have altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 equal parts. Do you see that? The thing that I had to do first was to realize that there were not equal parts, and I had to make equal parts. And when I have 2 hexagons, I need to divide them each into 6 triangles, which gives me 6 plus 6 is 12. Always do this first. Divide it into equal parts. Once you have it divided up into equal parts, then you can go ahead and make the fraction. I'll show you one more example, and then I'll let you get started. Here's another double hexagon. Okay, so what if they give you, let's see, this one's a little bit messy. I'm going to try one more. I'm going to make it a little bit more. There we go. Okay, a little bit better. What if I draw a line connecting this part to this part? That's supposed to be a trapezoid. Can you tell? Okay, here's a trapezoid. I'm going to color it. I think this line needs to be a bit more like this, and you'll see it a little bit better. Okay, there's my trapezoid. Now, can I write a fraction for this? You're right, I cannot make a fraction for this because this trapezoid is not equal to the rest of this shape of 2 hexagons. So my first job is to make equal parts. I'm always going to divide right down the middle between my 2 first. And now, this looks really funny, but this is supposed to be a trapezoid. I think because I'm drawing it, it looks a little bit odd. There you go, now you can see it a bit better. There's 2 hexagons there, or 2 trapezoids there. And then I need to create equal parts on this side as well. And I can do that simply by going like that. Now can I create a fraction? Sure I can. How many parts are counted? 1. How many equal parts are there now? 4. 1/4 of that double shaped hexagon has been shaded. So when you're doing question number 6, the first thing to do is to divide the shape into equal parts. Okay? That's important. Do that first. Divide the shapes into equal parts, then write the fraction. And when you're dividing 2 hexagons into equal parts, draw that line down the middle first to separate the 2 hexagons, and then think about where your center point is if you want to do triangles or connect opposite vertices to create trapezoids. Okay, so divide the shape into equal parts first for number 6, and then you can write the fraction. Okay, so that's basically it. Pages 57 and 58 are due today. So please make sure that you take a look at the instructions, follow them carefully. The first page does ask you about the characteristics of the shape, so you have to understand sides, parallel sides, and vertices. And then for questions 3, 4, 5, and 6, you are going to be writing fractions for those. Okay, But remember, before you can write the fraction, you have to create equal shapes first. Okay, so make sure you're connecting those dotted lines to create equal shapes. You cannot make a fraction if the shapes are, if the parts are not of equal size. Okay, all right, that's it for now. Bye-bye.